and very, very bad.
Yeah, my cousin is a doctor. She also had like problems with taste for like months. Like certain foods, like she just doesn't want to eat anymore. So
Really?
like, yeah, I mean, but it will dissipate. Apparently, like she's getting back to normal. Everything smells fine now. Like there's like one perfume that I bought her that she can use, and that's it. But you should
Lucky
be fine.
person.
I
Yeah.
just hope you guys are okay. Like that's the most important part. Don't worry about missing a tutorial or anything like that. That's fine.
Yes, no, we are good now.
Okay. So what can I help you with?
I can share my screen. I hope I don't have an issue. I don't remember which is the last thing we show you. I think we've seen these things about the agent and the organization.
I don't think he saw them.
This, I think we've shown them.
No, I think I've seen these before.
Okay.
Okay, and the initial studies for the hair
this one, yeah.
thing. Sorry, Ula, where is the agent development?
It's down.
The drop-down scenario, like we were thinking, because we couldn't easily direct them and decide where we want them, that they could start collecting humidity just in a higher altitude, and they just go down to the demand area.
Okay, so buoyancy.
Yeah.
Is going to be that thing. Okay.
We started cataloging like the capacity of holding water.
Okay. So like we were looking into like how much latticing there would be and how much humidity would capture through that latticing. So we have like in this one like little, and then we have average in this one, and then we have like two structured on in the next one. These are simulations with wind, for example, and the lattice formations in the middle. And this one is structured, how it would behave with wind and how like it's overly structured that we noticed. And then we started to look into a different patterning of this lattice. One is organic.
Okay.
Like this. And the other would be, oh shit, I didn't put the pictures. Okay. Sorry.
Is there something here?
Yeah, maybe you can skip it and then come back. I'm sorry.
No worries. Okay. 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 So you feel like even when they're falling down, they're just falling down the same, or what do you? So what kind of vector are you passing to it when it's going up? I see. Uh-huh. Hmm. So just for me to understand, like as they go up, they will collect these basically humidity particles, right? So there's some kind of value attached to these units that are collecting that says like, humidity levels in you are now, let's say 65. So once it goes down, it can emit the same number of particles on a lower level, which is equal to the amount that it collected. Uh-huh. Uh-huh. So right now, when they do this thing of like, I can see that they're removing something, right? Like, are they just being attracted to the? Okay. Okay. And then I see. So you're basically using attractive forces and then like releasing when you're low. Okay, no, that works too. I'm just thinking because that is a more of a physics-based model. Mm. I'm just thinking of ways in which we can kind of because the simulation is quite pretty, but I'm just wondering whether there's a way that we can approach it so that we can have a more systematic output. Because right now they go up, they attract, and as they fall, because when they fall down, how do they know which rate to fall down at? Okay, all right, good. So this is the part where it becomes, I think, important whether we can actually count the number of particles that are within their neighborhood, because that will tell us how much they've collected. Does that make sense?
Yeah.
Ah, I see. Okay, let's see. I see. Oh, so like every frame, it just like adds and adds and adds on top. Okay, so basically what needs to happen is that every time a loop is finished, you need to reset that, like you need to reset it to whatever it is before so that it doesn't add up every time. Because I think like probably in every loop, you're just adding the same weight again and again, no? Because like technically it should never be zero, right? Like in your system the weight should be constant, right? Because there's a certain amount of humidity which is expressed by these particles. It should always be that. So whatever you have in the beginning, that should always remain the case. So I think like either somehow you're emitting more and you're not aware of it, like the amount is changing. I don't imagine why else it would go up in size. It's a bit confusing. How do you calculate the weight? Is it just basically like number of particles and that's it? Or okay. Mm. Oh, okay. I think if you do you have embedded for loops anywhere? Yeah, sure. I think like probably somewhere you're not resetting the value and it's like multiplying it exponentially because it's within a for loop. So you have 8,000 agents. Weight plus plus. So let's yes. Yeah, yeah. Yes, but I think like before you enter the loop, like in the first part, you need to set the weight to 0 because you still don't know how many particles there are. And you also want to reset that value at some point to something else, right? Because in every frame, you're recalculating how much weight there is because some particles might leave your immediate distance and others might join. That's how you say that the weight of the cube is something. Yes, but you need to reset the weight within the loop as well because you should have an embedded for loop, right? Like for okay. Is the weight like a property, like a value that can be assigned to your particle, like that you can read at any time? So it's like in your constructor, there's something called weight. Because if you can query it at any time, can you maybe display the weight of each cube on top of your screen? Yeah, like each cube has a weight, right? Can we display that weight in each frame? Like instead of a cube, there should be text saying weight is something. Basically, I'm trying to like give you an option that if you can display that, then maybe you can follow at least in the screen what's happening. Maybe there's something just being calculated poorly in one place so that you can, you know, check it out. Because essentially what you're counting is the number of neighbors, right? There's a certain amount of particles that are around each cube at any given time within the range of 1.2. What is that number? That is your quote unquote weight, which is abstract. I think it's just about the fact that like whenever you pass from one frame to the other, you don't actually reset the weight to a 0. You add whatever you already had and then add again what you had. So like when you leave the loop, you should give it a 0 and then restart the loop. So I think maybe you're just out. Yeah, exactly. Like that. Maybe there you should put a 0 because I can't tell with all of the the parentheses, but it should be probably somewhere at the end. So like once the loop is finished, you can clear the data. But let's see, does the simulation change? So the simulation is the same, which just means that the way that the value is displayed is wrong, which is why I'm proposing that you try to display it on top of the cube. See whether that would change it. Like in the position of the cube, there should be a value that describes the weight. Mm-hmm. I just think like it's a rather simple thing. You just need to identify where you should be resetting it, because I can't tell from your screen. But basically, once you finish one loop of testing against a certain number of neighbors, you should be able to reset it for the next frame, like once everything is done. So maybe it's just like a parenthesis lower or something. Because the weight that you're displaying is also, I'm assuming, the entire weight of the entire system. That's what you're hoping for, right? Like, I'm not sure what is being displayed. That's what I mean. That's why I'm proposing that you try to add it as a value within your cube that you can display on top of the cube. Yeah. No, I'm not saying like do it now. I'm just trying to give you. Yep. Yes, which is called weight. Yes. Uh-huh. Uh-huh. Yes. Perfect. Exactly what you need to do. Okay. No, try. But I think you'll find your way, because it is like, seems that your script is working correctly in other respects. It's just about figuring out where this value needs to be passed and where it needs to be reset. That's it. Well, the simulation itself, like from what I can see, I'm glad that it's running. What I would be interested in next is that, because when they're falling down, again, you're saying that you're passing like a value that's a random one that makes them fall down. We need to relate the way that it falls down to the weight that they carry. I think that would be good to see, because then it's like an actual buoyancy thing, right? Like if some of them collected less humidity, they shouldn't get to go down as easily. You can even create like let's say a crucial point at which they start going down. Look, so maybe like between 0 and 60, they still stay up there, but then once it crosses 60 to 61, then they have the directive that they can go back down. Because I think like this process is where the design will be, like how you get to decide which one stays buoyant, which one needs to go down, and the repercussions of it going down. Because your system seems to be quite passive in like an interesting manner, like that it does behave like the weather. So I'm interested in where we can insert a little bit of more design thinking, or like how you're affecting the system. You can disturb this normal process of it goes up, it goes down, because that's basically the way in which water evaporates, sublimates, turns to precipitation, goes back down to the earth, and so on and so forth. Yes. Yes, on the weight, exactly. So basically, you will have a vector, which is like a vector that's pointing down, and then you can multiply that vector with the weight, which is a scalar number. So it's like, if I have 60 particles, my vector of like pulling me down is increased 60 times. So I'll fall down faster. I see. Well, you can bind the scene, like if you want, so that once they reach a certain Z, you kind of tell them at least to stay at that Z, or ask them to go down anyway. So it can be like an artificial decision as well. But for now, let's just see if you can relate those things together, like the weight with the amount of falling down. And it will also be nice to see like even these particles that we release, like how do they, I understand that it's humidity, it's basically water, but like it would be nice to see how this can also be included into the environment. Like how does this affect whatever's on the floor, whether it's like I don't know, like a depositing process or something happens to whatever's happening underneath that makes it relevant that this humidity was redistributed.
Yeah, we actually have a video. Show him, Yuji, the previous video where, yeah, where it was depositing on the ground.
Yeah, maybe they should change behavior when they are released. Like the particles, they shouldn't still float.
Yeah, could be.
They could
Yeah.
change their way that they are behaving.
Mm-hmm. I see. I mean, look, I think it's even valid for you to kind of whatever comes into whichever particle comes into the radius of the cube, it just gets removed from the simulation completely. It gets killed and becomes part of the cube in terms of like this weight that kind of tells you there's now like 50 particles should be part of this cube. And then once the cube reaches the ground, you can emit them however you like. You know, like from that position in the cube, you can emit 10 new particles, which you killed when you went up in the atmosphere. Does that make sense? So you can try to approach things in this way as well. Like it can be a more of database approach rather than a physics approach.
So in terms of legibility, like, do we need to have more colors to like define what is what? Like,
I think it would be easier, like just for people to understand like what's going on, like how to indicate what's happening.
So what do you suggest? What do we like? What is something
so like
that
you have obviously you have like these collectors and you have the humidity, which is represented by these particles. So I think like collectors are their own thing, particles are another thing. Is there a difference with the particle that's like floating in air and the one that is on the ground? If there is, then we should also change its color. I mean, you have colors here already. I just think in like these higher resolution simulations, we should be seeing a little bit more effect. I think like there's something happening that's positive, but it's still like a little bit like uncontrollable. But I think in general, the setup, as in like how you're approaching it, seems to be like logical and easy to follow. It's just that we need to see what we can actually do with this as a thing.
Yeah, and maybe, go ahead. Yeah, that's what I want to say.
Okay, that can also be like, especially if maybe certain humidity particles can have different values. Like maybe some of them carry more humidity or less. So then, like this kind of gradiated thing makes sense because a particle can be like denoted from something that goes from almost like white to deep blue, meaning like it has a different scoring amount of humidity within it, if that's what you would want. So then like, not every neighbor gets to be the same amount of points, so to speak, for the cube. Some might be like very humidity heavy as opposed to others. Like if we're interested in pursuing this thing of like, it's somehow relevant, there's a gradient within them. Yeah. Yeah, because right now you're just passing like one vector, right? Oh, I see. Nice. Nice. Yeah, I can see. Cool. Okay. I gotta go now, but like if you guys can work on this part of like trying to nail down this weight thing, I think we'll be able to progress it further, because then you can make decisions based on the amounts that you are collecting or neighbors that you have, which relate to the weight and the amount of humidity, which might end up giving us a bit more result.
We have one last part. Maybe if you have like a couple of minutes at least to tell us if this makes sense. So tell us when you have to go. We had this part with the data that we were trying to handle. And so we had like the topography data, precipitation and humidity.
Nice.
And in the beginning, we started seeing that as a way of like starting from a point and reaching to a goal point, which is of high humidity. And then we thought that it would be more interesting. We want our system to behave like a weather system. So we picked up 3 points that we could study these, taking into account topography, humidity, and wind, and add some kind of this is a slow simulation, but yes, it's reading the humidity data and the wind and topography, how our agents could start behaving like a weather system.
I think like this is interesting, but I think the important part with your system is that it actually affects this, let's say, original value, whatever it is within the system. So it's like you have your humidity, which is in this like very clear 2D grid, which gives you the humidity as it is right now. But interaction between that and your system should result in that humidity being redistributed. So I think like it's a good start, but I think what we need to be seeing, if you guys are interested in using this real input, is actually like a really large scale version and an abstracted version of your system in which we can talk about like, oh, you're actually able to move like this absolute humidity from one area to another. Like you're a separate weather system to the weather that we actually experience anyway, which is like a natural phenomenon. So I think like visually, I can understand where this is going and like make sense. But I would try to see whether we can actually integrate this with maybe it can also be Unity. It's just like a 2D simulation, which actually shows that how your system on a very large scale might be redistributing this. Do you know what I mean? Daphne, you're muted. I can't hear you.
Oh, I'm sorry. Can you see that here, like that the humidity changes?
Oh, I can see it now. Yeah, I couldn't see it before.
Yeah, in the previous one, the lighting was very bad and it wasn't obvious.
Yes, exactly. Yeah, exactly. I just couldn't see it before. This makes sense because this is basically what we're looking for. Like you're kind of positing that your system is like a parallel weather system within the world that somehow is affecting how the natural weather is behaving.
Yeah,
I think like if we can have like a bit more thinking in this direction, that like these maps will become more relevant as tests as well. We can just treat them as like a more abstract representation of your system because it's like something that's on a massive scale. Maybe it's like millions of your units or something. So it doesn't necessarily mean that like 1 point corresponds to a unit. We're just going to talk about large volumes maybe.
So you think that it would be also more helpful to see a larger map, a larger piece of map?
I think we can do that, yes. It's just that we can just kind of specify that you're thinking about something that's like a larger scale, so we can abstract certain things. It's just that, let's say, the Unity stuff then should provide a bit more clarity into how this can be abstracted into rules for your large scale stuff. So it's like, maybe it's about saying like, within your population, a population might have the ability to travel the largest distance of 100 kilometers. I mean, maybe not, but just set a certain value, which limits the amount that you can affect within your system unless a certain amount of time is input so that the unit can travel from somewhere else. So you can localize these things a little bit more. So it's not like we're assuming that like your cloud is, traveling light speeds across the entire planet, but we can kind of say that, this is 1 week, 2 weeks, 3 weeks. It takes time for us to build up this kind of situation in which we can affect the distribution of humidity and therefore precipitation within a weather system. So it's like maybe a more of a thing that where you kind of slowing how it slowly establishes as a parallel weather system.
Yeah.
Mm-hmm.
Okay, so we will add all these factors like time, and we'll be more clear with the distance.
Because I think like some constraint of that sort makes your simulations easier to follow, and also introduces a level of scrutiny on your part. Like you're kind of saying like, we're not just observing this like in a completely unbounded fashion. We are thinking about like the limits that we've seen in a lower level simulation that we saw in Unity, for example. And then from that, we assume that there are certain timescales that we need to follow, distances that we can cover, certain general outputs that we can expect that bound or give constraints to the simulation as it is.
Yeah.
Okay.
Sure. Yeah.
Sounds good.
You.
Yeah. Nice
Alex, in terms of Maya, I have some issues, but maybe if you are like, we can ask later. If you need to go.
If it's really quick, let's do it.
It's like it's from the M particle simulation, and when I change it into polygon, like from N particle to polygon, and reset the values and to make it's become a whole piece with the polygon system. But when it's export to FBX or either Alembics, it's never work. But if I just create a mesh like or polygon module, it's worked. So I don't know why this happens. Like
well, if it changes the polygon over time, which is basically what happens when you translate or like convert particles into polygons, the only way to embed this information is as an Alembic file, because it's a playable file. Even in 3ds Max, if you opened it, it would still play. But you cannot export as an FBX because it just exports one frame. So it will probably only export frame 0, which is probably empty because there's no particles in the scene yet, or something like that. Like you basically need to convert to a mesh and then confirm that when you convert that it actually ends up being a mesh, because sometimes the settings for the output of the mesh are not correct. So your scene just appears empty even though it's not. So like when you convert your particles into a mesh, do they appear as a polygon? Do you see it?
Yeah. I could say it's after I turn the values. I could say it, and it's work.
And then when you play it, does it become this polygon that changes?
Yeah, it's animated. Yes.
Okay. So then when you select that polygon, you need to export that selection into Alembic, and Alembic is importable into Unity. So that doesn't work, or it does work?
That doesn't work.
So obviously, like there's two options that you have. Like you can bake every frame with animation snapshot, or try to see whether you can kind of fix the Alembic thing, because I feel like the Alembic should work, and I know that it works in 3ds Max. I think it's even importable into Cinema 4D, but I've never tried to import it into Unity. I just know that there is an option. So when you
works. Yeah, I think the particles are the issue, because it works with other polygons.
Yes.
Yeah. Yes, exactly. The thing is like when you export to Alembic, the thing you could do previously, maybe this will help. You can cache the particles first. So cache them to a file, and then convert, because then it's scrubbable. You can like play it however you like, and then export them to Alembic.
Okay.
Make sense?
Okay, sure. I'll try it. Yeah, thanks.
Okay. All right, guys. I gotta run, but I'll set up another meeting. I think like the air team couldn't join today, so we'll see whether it's this week or next. Anyway, good progress, and keep working. And maybe, I don't know, in one of the following meetings, either even maybe next one, we can also look at presentation structure, because your presentation date is pretty near, and it's important for it to be really clear. All right. Thanks, guys.
Okay,
Thank
thanks.
you, Alex.
Bye.
Bye.
Bye.